Welcome back. Let's dive into this week's material. And this is what I think will be one of the most exciting and practical lessons. We're going to bridge two critical topics: understanding how businesses will organize and use their data, then learning how to actually work with that data using Python and some AI tools. So before we dive in, let me share something that should wake you up. A 2024 study analyzed over 35 years of research found that 94% of business spreadsheets contain errors, not typos or minor issues. We're talking about errors that lead to financial loss, wrong pricing decisions, and operational disasters. Just last year, banks implemented advanced analytics, saw corporate revenues raised by over 20%. The difference between companies thriving and struggling often comes down to how they actually manage and analyze their data. So let's dive into a topic that many of you probably heard, may not understand. What is an information system? It's fundamental. So let's start with the basics. An information system isn't just technology. It's a combination of three critical components working together. First is people, which are your users, analysts, managers, and any decision maker who interacts with a system. The next is procedures. These are the process and workflows, how data flows through your organization, who can access it, and how it's collected and stored. And then thirdly is technology. It's all your hardware, software, databases, and networks that collect, store, process, and deliver information. So what is an information system's ultimate purpose? It's to support decision making within inside of your organization. Every piece of data, every system, every process should help someone make a better decision. So let's dive into some real world context, the AI revolution in business systems. Here's what's happening right now in 2026. According to recent industry studies and surveys, 65% of organizations have adopted or are actively investigating AI technologies for data and analytics. This isn't future talk. This is today. So let me give you some examples here. Gordon Food Services unified 170 plus data sources using modern analytic platforms, creating an AI ready foundation. The result? It improved real time response to critical business needs. It increased their customer adoption for their ordering applications, which reduced costs and gained market share. Next is General Mills saved over $100 million by giving employees secure access to AI language models that can answer questions based on both structured and unstructured data. Topic we'll cover more here in a little bit. Think about that, $100 million saving by better information access and decision making. So what is the data lifecycle? Understanding the journey of data is important. Data doesn't just appear magically in reports. It goes through a life cycle, and understanding its life cycle is critical for anyone working inside a business today. So let's walk through each stage for the next couple minutes. The first is the generation. These are transactions are happening all day long, everywhere, all the time. Every time you swipe your credit card, make an online purchase, use your mobile app, or even scan an item at a point of sale system, you just generated data, which leads to collection. It's the raw data that's captured at the point of a transaction: the item's name, pricing, timestamp, customer IDs, location data. You can think of this as metadata as well. Next is storage. This data gets saved in files, spreadsheets, or databases, either on-prem in a company server or within inside of the cloud in Azure, AWS, or GCP. Next is database management, which is a central repository organizing and managing structured data for easy retrieval and analysis, which leads us into processing. The data gets cleaned, validated, and transformed. We convert timestamps to standard formats. We remove errors and handle any missing values. This is where analysis comes into play and where business insights happen. You're identifying sales trends, detecting fraud, you're segmenting your customers, and you're predicting future behavior. Now you need to visualize this data by creating dashboards, charts, and reports that decision makers can actually use and understand. Lastly is disposal. When data is no longer needed, it's either archived for compliance purposes or securely deleted. So what are some current AI trends that align with the data lifecycle? What's particularly exciting right now is how AI is transforming each stage of this life cycle. Last year in 2025, predictive analytics powered by AI has evolved into a cornerstone of strategic decision making. Companies can now anticipate market trends. Thus, customer behavior is becoming remarkably accurate. The AI analytics market is exploding. The creator economy for analytic AI market has grown by 3.24 billion in 24 and last year almost 4 billion. That's a 20% growth in a single year. Projections by 2029, it's going to reach over 8 billion. So let's talk about structured and unstructured data. Because these types help you distinguish and it's fundamental to understand how business work with the information. First is structured data. This is how it's organized in rows and columns. Think spreadsheets and databases. Each row represents an observation, like a customer, a transaction, or a product. Each column represents a specific value or variable, such as your price, the date, the quantity, or customer ID. Some examples are sales numbers, customer information, inventory counts, your financial transactions, or even product reviews with ratings. Where unstructured data, it doesn't fit neatly into rows and columns. These can be images, videos, audio files, your social media posts, any of your consumer service chat logs, emails, or any free form text. Think of your product photos, the videos of the self-driving car for training, the customer support conversations inside of their chatbots, or social media sentiments. So why does this matter for business? Business run on data, but here's the critical insight. Poor data quality equals poor decision within a business. When data is disorganized, error-filled, or inaccessible, companies will miss opportunities, make costly mistakes, and lose customer trust. Organized and trusted data, on the other hand, enables compliance, efficiency, and builds customer trust. More importantly, structured data is the foundation for analytics and AI. You can't train an AI model or run predictive analysis on messy, unstructured information. According to PwC's 2025 Responsible AI Survey, 60% of our executives say that proper AI implementation boosted their return on investment and efficiency, while 55% reported improved customer experience and innovation. But this only works when the underlying data is well organized. So let's talk about files, folders, and the critical role of metadata. Let's go back to the basics. This might seem basic to you, but a proper file organization is where many businesses fail. Let's define these terms. A file are containers of data, your spreadsheets, the documents, your images, your databases. Folders are organizational systems, the structure you use to organize and locate files. Metadata is the data about the data. Who created the file? When was it created? What type is it? When was it last modified? Any version numbers, tags, and so on. So let's talk about some bad practices versus some good practices. File names need to be unique, such as report final version.xl or copy of a copy of a copy. This is a disaster waiting to happen. Bad practices include inconsistent or missing metadata, no version control, unclear naming files, multiple people creating multiple copies without coordination. Good practices consist of using year, month, day, report, the version, and then the MIME type such as Excel, so XLSX. Proper tagging with creator, version, and department information, centralized storage with clear permissions, and automated version control. Why do businesses depend on metadata? Metadata isn't just nice to have. It's essential for compliance and audits. Your regulators or auditors will ask for documentation. You need to find the exact version of the file for a specific date. Without proper metadata, this becomes a nightmare. Searchability and discovery is important. Employees need to be able to find information quickly. Good metadata makes files searchable and discoverable across your organization. System integrations are imperative. When different business systems need to share data, metadata ensures that you're talking about the same thing. So why are spreadsheets a problem inside of business systems? The business system landscape. All business systems depend on structured data to function. Let me walk you through this again for the next couple of minutes. Spreadsheets are an entry-level system that's most accessible and flexible for small-scale business operations. Where customer relationship management, or CRMs, these are systems like Salesforce that track customer interactions, your sales pipeline, your relationships. Where ERPs, your enterprise resource planning, are integrated systems like SAP that connect finance, supply chain, manufacturing, and other business units. Where your human management systems, or human resource management systems, your HRM, these are systems that manage the employee records, your payroll, your benefits, and your performance. So, could you imagine all this in a spreadsheet? That would lead to a crisis, real numbers and real consequences. This is where things get serious. Remember 94% error rate I mentioned? Let me give you some real world disasters that happen because of spreadsheet errors. In 2012, JP Morgan London Well, a trader named Bruno lost at least 6.2 billion. Yes, billion with a capital B, after errors in a risk model involved copy and paste across multiple spreadsheets. The formula divided by the sum instead of average. One formula led to over 6 billion in losses. Next is 2020, the UK COVID testing failure. The UK public health system missed 16,000 COVID-19 test results because of an Excel spreadsheet reaching its row limit. This spreadsheet failed. The failure delayed critical public health response during a pandemic. Think of 2016, Lazard Investment Bank. A computer error in a spreadsheet led to a $400 million inadvertent discount when advertising SolarCity Corp on its $2.6 billion sale to Tesla Motors. The spreadsheet double counted projected debt. Fidelity in 94, they made a huge clerical error, miscalculating a capital loss of 1.3 billion. The accountant omitted the minus sign and treated a loss as a gain, affecting dividend estimates by close to $3 billion. The latest data from 2024 shows that 140 public companies in the first 10 months alone told investors that previous financial statements were unreliable or required restatements, a 9-year high. Many of these errors trace back to spreadsheet mistakes. This is why spreadsheets fail. The problems with spreadsheets for large-scale operations include there's no version control. Multiple people create multiple versions, and nobody knows which is the current version. Manual data entry. Humans make mistakes. Yes, you and I have typing errors, copy and paste failures, and we mix up our formulas. There's no audit trail. You can't easily track who changed what and when, which leads to poor scalability. What works for 15 rows fails catastrophically when it becomes 15,000 rows. There are security issues as well. According to research, 68% of spreadsheet data breaches result of a human error, with 54 from an accidental disclosure and 84% of those involving email attachments. So let's transition to move beyond spreadsheets. Let me be clear. Spreadsheets aren't evil. They're great for small data sets and quick analysis. The problem is when business outgrow them, but they keep using them anyway, because that's what everyone knows. But here's the reality. Businesses today need scalability, automated, and repeatable analytics. When you are dealing with thousands or millions of rows of data, you need to update analysis daily or hourly. When multiple teams need to access the same data, spreadsheets become a liability. So we have to progress from spreadsheets to enterprise solutions. So it looks like this: spreadsheets to databases, databases to business intelligence tools, to Python/program, which leads us to our AI machine learning. Each step in this progression gives you greater data capacity, allowing you to handle more rows and more complexity. It gives you better automation, reducing the manual work and our human error. It gives us more sophisticated analysis as we move from descriptive to predictive to prescriptive analytics. It improves collaboration, multiple users, and a single source. There's better governance as we can track changes, enforce rules, and maintain compliance. So now enters Python. Why Python? Python has become the language of choice for business analytics for several compelling reasons. It's open source, free to use, with a massive community contributing to libraries and tools. It can easily handle large data sets. Unlike Excel's 1 million row limit, Python can process billions of rows. Python enables automation, write code once, run it repeatedly with new data. It supports advanced analytics, from basic statistics to machine learning and AI. It's very powerful as it has many libraries such as pandas for data manipulation, which we'll use in our lab, the matplotlib for visualization, and then many others for machine learning. So the numbers speak for themselves. In 2025, 78% of organizations reported that they used AI at least in one business function, up from 55% the year before. Private investments in generative AI alone is a almost $34 billion in 24. Companies like Intuitive have created what we call AI factories, an internal infrastructure called GenOS, which is a generative AI operating system for business that allows their team to build AI solutions effectively. Procter & Gamble has done the same thing. These companies understand that you need the right infrastructure to scale analytics effectively. Let's talk about Google Colab. It's a free Python environment, which is a free cloud-based Juniper Notebook environment. This means you don't need to install anything on your computer. The Python runs directly in your web browser, and you can save your work to your Google Drive. It's completely free and accessible from anywhere. Here's where it gets more powerful. Instead of memorizing every Panda command, you can use AI tools to help you write the code. Let me demonstrate using Gemini, the Colab. Let's say you want to calculate the total revenue by region. Go ask Gemini to write this. Write Python code to calculate total revenue by region from its sales dataset. The AI will generate code that groups the data by region and sums the revenue. This is the future of analytics. You focus on the question you want answered, and AI helps you write the code. To get there, remember, always double check the code. Compare different AI tools. For your assignment, I want you to try the same prompts within ChatGPT, Copilot, Claude, or Gemini. Ask each one. Write Python code using pandas to calculate average profit margins by customer segment. Test each solution in Colab. Which one gives you the best code? Which is most accurate? Which explains the code most clearly? This is critical thinking applied to AI tools. Don't just trust the first answer you get. Now let's talk about visualization. Python can create visualizations using the matplotlib library. Ask your AI assistant, write a Python code to create a bar chart showing revenue by channel from this sales dataset. Run the code and you'll see a professional chart appear right in your notebook. You can export this, include it in reports, or modify it as needed. So let's talk now about some real-world context and future implications. The analytics market is exploding. We've talked about this numerous times. Let me put the current thought into perspective with some recent numbers. The global big data analytics market is projected to leap from 350 billion to almost 924 billion by 2032. That's almost tripling in less than a decade. The conversational AI market of natural processing is estimated at 12 billion in 24, is expected to reach 41.5 billion by 2030. By 2028, it's projected that 33% of enterprise software applications will incorporate agentic AI. AI can set goals, plan tasks, help with actions, and adapt based on your feedback. This is going to be a big career changer. Every business function is being transformed by data analytics and AI. Finance and accounting, banks are implementing advanced analytics, have seen corporate revenues raised by 20%. Financial institutes are heavily investing in data analytics for fraud detection, risk management, and to help personalize their product offerings. Retail and e-commerce are focusing on AI to help them grow at 20% or more over the next 5 years. Companies use analytics for inventory optimization, price optimization, help with their customer segmentations, and again, to give you personalized recommendations. The healthcare industry is enhancing its predictive capabilities, automating complex tasks, and providing deeper insight for patient care. Supply chain and logistics. Companies like J.B. Hunt are transforming logistics by consolidating fragmented systems onto a unified analytic platform. So here's the importance. There's skills gaps and opportunities for you. According to a recent survey where AI adoption is accelerating rapidly, many companies struggle to implement effectively. Nearly half of the respondents in the PwC survey said turning AI principles into operational process has been a challenge. This means companies need people who can. These people need to understand business problems and translate them into analytical questions. They need to be able to work with data using tools like Python. They need to be able to leverage AI assistants to accelerate their work and be able to communicate findings to non-technical stakeholders. Think critically about data quality, biases, and ethical implications. So AI as a helper, not as a replacement. Let me be very clear about something. AI assistants are useful helpers, but they're not replacements for understanding. You still need to know what questions to ask, how to evaluate the answers, and whether the code actually does what you need. Think of AI tools like a smart calculator. A calculator can multiply large numbers instantly, but you still need to know when multiplication is the right operation for your problem. Similarly, AI can write code quickly, but you need to understand what the code is doing and whether it's correct. When to use different tools. Only a human will know this. Different situations call for different approaches. So, you'll use a spreadsheet when you have a small data set, let's just say less than 10,000 rows, to do quick ad hoc analysis that you want to share with your non technical users who know Excel or are doing a one time calculation. You'll use databases when you have large amounts of data where you need multiple user access and require strong data integrity, or simply want to separate data storage from the analysis. You'll use Python when you want to automate, or when you're working with large data sets, thus wanting reproducible analysis that also needs advanced analytics or even machine learning. Or if you just want to simply integrate multiple data sources, it's easier with Python. AI assistants will help you write this code quickly. It'll help you learn new techniques. It'll help you with your debugging, or if you just simply want to explore different approaches to a problem. Which leads us to the importance of validation. This is critical. Always, always, always validate AI generated code before using it for a business decision. Run it on sample data, check if the results make sense. Verify the logic. AI can and does make mistakes, sometimes subtle ones that seem correct at first glance. But remember, these spreadsheet disasters we discussed, many could have been prevented by simple validation and double checking. The same applies for any AI generated content and code. I want you to practice with the sales dataset. Use AI assistants to help you answer the following questions. First, what region had the highest average contribution? Second, what marketing channel produced the highest revenue? Third, plot the revenue trends by month. For these questions, try at least two different AI tools: Gemini, Claude, Copilot, or even ChatGPT. Document which prompt you used. Record which tool gave you the best results. Verify again the code actually worked and produces correct results. Here's what I expect you to learn. You'll be able to demonstrate proficiency in loading and exploiting datasets in Python. You'll be able to use AI tools to generate this code. You'll learn how to compare the different results between the AI assistants, thus creating visualizations that you can use to communicate findings, thus validating results and being able to critically think about the code quality. So think about this with me as we wrap up the analytic journey. Talk about descriptive, predictive, and prescriptive again. What we've done today is describe, its first is descriptive analytics, understanding what happened. This is the foundation, but it's just the beginning. In future lectures, we'll move on to predictive analytics. What will happen using historical data to forecast future trends, customer behavior, sales, and more. We'll talk about prescriptive analytics. What should we do? Using optimization and simulations to recommend actions that achieve business goals. We'll move from spreadsheets to Python. This is an important question you need to think about. And here are the key indicators. What is your data volume? When you regularly work with more than 10,000 rows, Are you hitting the Excel limit? Is it repetition? When you find yourself doing the same analysis weekly or daily, it's a sign you now need to automate. Use Python. What is the complexity? When formulas become so complex that nobody else can understand or maintain them, it's time to automate. And do you have collaboration issues? When version control becomes a nightmare with multiple people editing multiple files, it's going to lead to error frequency. Remember again, those spreadsheet mistakes start causing real business problems and financial losses. You need machine learning, text analysis, or other advanced techniques to meet your needs. So here's our key takeaways from today's discussion. First, information systems combine people, process, and technology to support decision making. Data quality is critical. 94% of spreadsheets contain errors, and those errors will cost billions of dollars. With proper metadata and file management, you can essentially gain compliance, searchability, and system integrations. Businesses must scale beyond spreadsheets as they grow to handle larger and larger data sets, enabling automation and reducing our error rates. Python is becoming the standard for business analytics because it's scalable. You can automate and you can integrate with the today's AI tools, such as ChatGPT, Claude, Gemini, as they're powerful helpers. But you, as the human, must validate their outputs and maintain critical thinking. Again, the analytics industry is exploding. 65% of organizations are adopting AI for analytics. The market is growing to almost 350 billion to almost 900 billion within a few short years. Here's my final thoughts. We're at an inflection point in a business history. The companies that master data analytics and AI have enormous advantages. The professionals who can work effectively with data, leveraging AI tools intelligently, and communicate insights clearly will be in high demand across every industry. What you're learning isn't just academics. It's immediately applicable in today's job market. Every role in business, from marketing to finance to operations or HR, is being transformed by analytics. Remember, Python and AI are tools. Your job is to understand business problems, ask the right questions, validate the answers, and communicate findings effectively. The technology will continue to evolve, but the fundamental skills will remain valuable. So let's wrap up with a few questions. What did you like about today's demonstration? What are you more curious about? Thank you for your time today. Now let's get started on those practice examples. Let's make sure you're comfortable with the basics of Python and AI-assisted analytics. So until next time, stay safe and stay secure, everyone.